Polar is just a different way to represent a point, okay? A polar graph looks a little bit different. If you look at this graph right here on your notes, that's a polar graph. You will never have to recreate that graph, okay? If we ask you to graph something or plot something, we will give you that graph. Kind of like the inverse sine and cosine, we gave you that coordinate plane. You will be given this graph right here. Notice there are some extra. That's just the pi over 12. So if this was what that is right there, pi over 12. So we could use that, but it's usually just not labeled on the ones that we give you. All right, so here, this is 0, 0, just like it's always been. If we were in rectangular, that's just our normal xy points. We would go x and y, and that would be our xy point. If we're in the polar coordinate plane, this point right here goes out, so it goes with the radius. So it's the radius and then whatever angle we're at. If we're in quadrant 1, we're somewhere between 0 and 90, or 0 and pi over 2. We're going to use radians always, so 0 and pi over 2. If we're over here in quadrant 2, somewhere between pi over 2 and pi. Now, we can go both ways, positive and negative. And even the r can be negative. And I'll show you how to do that here in a second. But that rectangular point can be changed to a polar coordinate point. It's in the same place. It's just named something different. And the point is r comma theta. Now, how you go from one to the other. Right here are the little formulas that you'll have to know. You won't be given those. Okay, so if you are given the r theta, so you're given the polar coordinate, and you need to find the x and the y. It is a simple formula. X equals, you plug in the r value, you multiply that by the cosine of the angle given. So since we don't have a calculator today, that angle given will be something that's on the unit circle. X goes with cosine, y goes with sine. Still the same from unit 1. If you're given the opposite, you're given the xy, and you need to find the r comma theta. X squared plus y squared equals r squared. Now, in this case, when we solve for r is going to be plus or minus, because when we take the square root, r equals plus or minus whatever the square root of x squared plus y squared is. So we have to pick which one. We can't just pick whichever one we want. Okay, it depends on the problem. We could pick the positive or we could pick the negative, but it's got to match our angle, which also has to match the original point given. Okay, so it all has to match. Now, this says x can equal 0. Let's take that out because x can be 0. It's just undefined. So if x is 0, we're just looking for the points up at pi over 2, 3 pi over 2, negative pi over 2. So it is possible for x to be 0 because there is an angle where tangent is undefined. And that's just at the top and the bottom of the unit circle. This one we would just solve. So this goes back to unit 3. The inverse tangent of y divided by x is going to give you your angle. Now, because we're not worried about principal value, you can find all kinds of angles. There are an infinite number of correct answers for that one. You can go in a positive direction, negative direction. You can find coterminal angles. It all just depends on what the problem states. It might give you an interval that you have to find. It finds something between 0 and 2 pi. Or it just might find whatever you want. So it just depends on the problem, and we'll do some examples of that today. Now, first, so before we can do that, we have to understand where those points are plotted. So here are 4 different points. Now, notice these circles right here. Those are like the radius, so the rings. Here's r is 1, 2, 3, 4, 5, 6, 7. So it goes up to 7 right here. And then the points around there are labeled for you. They won't be blank. They'll be on there for you. All right, so 1, 3 pi over 4. We go out 1 ring, and then we go over to 3 pi over 4, plot that point. So there's your first point right there. That's all you do. Number 2, 3. We go out to 3. 1, 2, 3. Negative pi over 6. Negative pi over 6 means we go down a distance of pi over 6, which is clockwise. So there's point 2. Remember, clockwise and counterclockwise, that's going to be important because sometimes we go the other way. We start going to the left instead of the right. And then we have 5, 3 pi, so we go out to 1, 2, 3, 4, 5. And then there's 1 pi, 2 pi, 3 pi. So there's 0.3. Now, nothing's changed. These are still all the odd pi's. So if I said find 5, 357 pi, would that point change? No, because it's still odd. We don't have to count 357 times. All the odd integer pi's are here, positive or negative. All the even integer pi's are over here, positive or negative. Okay, so that hasn't changed. Now, number 4, there's a couple different ways to do that. I'm going to show you both ways, and you can pick which way you like the best. The first way I'm going to show is the way I like it, because sometimes we have to work backwards, and it's kind of harder to work backwards the second way that I show you. Okay, so -4, positive pi over 4. So if I go -4, so this is positive, so just like a regular, I would go to the left, which is negative. So 1, 2, 3, 4. Now, if I want to go a distance of positive pi over 4, we don't go up or down. Okay, angles aren't up or down when we're talking about positive or negative. It's clockwise or counterclockwise. So remember, if I was over here, positive goes in a counterclockwise motion, negative goes in a clockwise motion. So if I'm over here at -4, I want to go a distance of positive pi over 4, so that leads me right there. The other way to do that is to ignore that negative for a minute and go to 4 pi over 4. So if I went out to 4 pi over 4, and then since the r is negative, I slide it across to the opposite quadrant, whichever one you like. It doesn't matter. Okay? You can go the negative and then go in the positive or negative direction, or you can ignore the negative and then slide it. Either way works. Doesn't matter to me which way you do. It's just whatever makes more sense to you. Now, all those points, we could come up with something different that equals the same thing, but the r is the same. R can be positive or negative, but it all depends on the angle that goes with it. Okay, you can't just change it to positive or negative. If you change it to a negative, then that's going to affect the angle, which we'll see in this next example. All right, so it wants you to find 2 other polar coordinates, 2 with r is greater than 0 and 2 with r is less than 0. So we can't change r. R is going to be 2. We're on that second ring no matter what. Okay, r is either going to be positive or negative 2. Now, you don't have to have a graph. It's just there to help you use. So we know we're going to have 2 something and 2 something. And then we know we're going to have -2 something and -2 something. Okay, because r is greater than 0, we want 2 other ones where it's greater than 0. We want 2 other representations where it's less than 0. So in this problem, the r cannot change. It's the angle that's going to change. So if I were to plot that point, I'd go over to 2 and pi over 3. The easiest thing is, if I need to get back to that point, is just add or subtract 2 pi. It's just a coterminal angle. So if I go out to 2 and I'm up here and I need to get back to that point, add 2 pi, add 2 pi. You like subtracting better? Subtract 2 pi, subtract 2 pi. Okay, so if I'm at pi over 3 and I need to get back to pi over 3, I need to add 2 pi, which is 6 pi over 3, and so I get 7 pi over 3. I could add that again, and I get 13 pi over 3. Now, it might say, give me an angle that's somewhere between -2 pi and 0. So it wants you to subtract. So then you would just have to subtract 2 pi if it wants it in a certain place. Or it might say, I want it to be in between 0 and 2 pi. Well, how do I do that? Well, remember, we could have gone to +2 and gone in a negative direction. Okay, we could have done that also. So the distance that we went was 5 pi over, what were we at? Let's see. 4, 5, 10 pi over 3. So 5 pi over 6, 10 pi over 5 pi over 3. So 5 pi over 3 would also be an angle that would work with the 2 if we were getting back to that one. There's lots and lots of different ones. So I could go 2 pi over 3, or I could go 2 -5 pi over 3. That gets me to the same place, no matter what. Okay, no matter what, that gets me to the exact same place. -2. All right, so again, whichever way you like. I like saying, okay, if I go -2 right here, I could go this way, or I could go this way to get to that point. I've got to figure out which way. Do you like, now, up and down, again, we can't think up is positive and down is negative. That doesn't work with angles, clockwise and counterclockwise. So the pink right here, if I just like positive, I want to go in a positive direction. So if I started at -2, how far did I go? Well, this was pi over 2, this was pi. Or we can think 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7, 8 pi over 6. So that would be 4 pi over 3, if we were to simplify that. Or you could have done the blue, okay, and that you went 2 pi over 3, but we went in a negative direction because that was clockwise. So we could have said -2 pi over 3. Or you could have just added 2 pi to the 4 pi over 3 and got 10 pi over 3. That would work also. There are lots and lots of correct answers for these. But you can't mix and match. Like the -2 and the 7 pi over 3 can't go together because that takes you to a different place than -2, 4 pi over 3. So negative direction for R. This is still negative because we're going clockwise. Positive because we're going counterclockwise. That doesn't change. Like here, this was 0, this was pi over 2. So counterclockwise is still a positive direction for angles. Clockwise is a negative direction for angles. Questions? Okay. All right, then the last part is just going from one to the other. Okay, so using those formulas. So we want to find the rectangular if they give us the polar. So it gave us r theta. So we use our x equals r cosine 2 pi over 3. Y equals 4 sine of 2 pi over 3. So this is where we have to remember our unit circle a little bit. So think back to here's 2 pi over 3. So that's -1/2 root 3 over 2. Those signs are very important and they have to match that original point for 2 pi over 3. If we think back just a second ago, if I were to graph that, so 1, 2, 3, 4, 2 pi over 3, so we're in quadrant 2. So our answer, our coordinates that we get should be in quadrant 2. X equals 4 times -1/2. So x equals -2. Y equals 4 times root 3 over 2. So y equals 2 root 3. So my x value is -2. My y value is 2 root 3. Is the point -2, 2 root 3 in quadrant 2? It is. X is negative, y is positive. So there are your rectangular. Rectangular is just your normal xy that we've always plotted. So the signs are important. If you forgot about that -1/2 or got them flip-flopped, and maybe you got 2 negative 2 root 3, that would have been in quadrant 4. And quadrant 4 and 2 aren't going to produce the same point. The rectangular and polar have to be at the same place. It's just a different way to represent it. All right, now the opposite. We want to find the polar given the rectangular, x and y. So r squared equals x squared plus y squared. So r squared equals 4 plus 4, which is 8. So r equals plus or minus 2 root 2. We don't know which one we want to use yet. Just because the x is positive doesn't mean the r is positive. It could be, but we can't just make that assumption. All right, and then tangent of theta equals y over x. So tangent of theta equals -1. So if you want to do one more step, inverse tangent of -1 equals theta. Now, it doesn't say anything about principal value. It doesn't give us any kind of restrictions. So there's lots of places that happens. So let's think about our unit circle. Hey, where would... So what angle? We're looking for the angle. So where is the y and the x the same with opposite signs? Right here, right? 3 pi over 4. Or 7 pi over 4. Or negative pi over 4. Do all those make that true? Tangent of negative pi over 4 is negative 1. Tangent of 7 pi over 4 is negative 1. Tangent of 3 pi over 4 is negative 1. All of those are true. So we just got to figure out which one we want to use. So we look here, 2, negative 2. What quadrant is that? 4, right? 2, negative 2. So we want to use one of these. Now we just have to decide, are we going to use the positive or negative 2 root 2? There's lots of choices. You just got to pick one. So let's say I want to use positive 2 root 2. So 2 root 2. So if I go out 2 root 2, could I go around or down? Could I do either one? Yeah. Could I get to that point if I go in a positive direction and get to 7 pi over 4? Or could I get to that point if I go negative pi over 4? Either one works. Doesn't matter which one you like. You like positive angles, use positive. Either one works. 2 root 2 goes with 7 pi over 4. Positive 2 root 2 goes with negative pi over 4. It's the same. If you had decided to go left and then around, that would have affected your angle. Or left and then up and around, you could have done that also. All right, back to rectangular from the polar. So this is r and theta. And really, finding the rectangular, that's the only time you have to worry about the plus or minus. Because this one is just x equals and y equals. Just find x. X equals 2 times cosine of pi over 2. Y equals 2 times sine of pi over 2. So again, if you need that unit circle out to look at it, get that out. Keep that with you in your binder if you need it. So that's 2 times 0, which is 0. 2 times 1, which is 2. So 0, 2. So again, think about it. 0, 2 is right here. 2 pi over 2 is right there. It's at the same place. The rectangular and polar will be at the same place. You don't have to graph them, but it's helpful if you want to. All right, and the last one, it gave us x, y. We need to find r and theta. So r squared equals 1 squared plus root 3 squared. 1 plus 3 is 4. So r equals plus or minus 2. Anytime you take the square root, it's plus or minus. If the square root's already there, it's not plus or minus. If I just said, what is the square root of 4, that's just 2. But this isn't asking what the square root of 4 is. This is asking solve for r squared. So we put the square root. We put the square root in the problem. That's when it creates the plus or minus. And then over here, we have tangent of theta equals y over x. So if you want to go one more step and write this, you can. You don't have to. Either one of those would be fine for work. So we just got to figure out which, is it pi over 6 or pi over 3, where that happens. At pi over 3, we have root 3 over 2, 1/2. I'm sorry, pi over 6. And at pi over 3, we have 1/2 root 3 over 2. So which one of those gives us a root 3? This one right here. So theta equals pi over 3. So our point, root 3 is in quadrant 1. So if we go out 2 places and up to pi over 3, we can just use the point 2. Pi over 3 would be our answer.